What is up, people? Hey, guys! Who does that remind you of? That's right, Miss Maley. She ain't even here for me to make fun of her. We're on page 168. We're going to do the key concepts all about functions. Okay, different representations of functions. Tables, graphs, linear functions, non-linear functions. Okay? Yeah, even equations, guys. Okay? So anyway, let's hop to it here. What are the different representations of functions? I think I just mentioned a whole bunch of them. What were they, guys?
There's 3 of them.
So, guys, yeah, we have an equation, right? There's one. Y equals negative 50x plus 720. Way number 2, we can have a graph, right? It could be linear or it could be non-linear. What was that third one? That's right. Third one, guys, is...
Starts with a T.
That's right. Table. Okay. Again, we've seen tables, graphs, and equations. Now we know they're all about functions. So, okay, there we go. Question 1. How can you use a graph to determine that a relationship is not a function? So we talked about this in example 3. Right, if we have a graph, right, we can use this test. What was that test called? Yes, it was. We will use the vertical line test. Can somebody explain what that is again? So guys, yeah, remember, that's where we draw a vertical line, right, that goes through our function. As many vertical lines as we can, and if it only goes through the function one time, right, then it is still a function. Okay?
I love the vertical line.
Yep, it's a great test. We all love it. All right. Must the ordered pairs of a function be connected by a straight line or a curve on a graph? Explain. No, guys, they really don't have to be. So this might be a little bit more than what you need to know, but we have 2 kinds of graphs out there. We have what we call continuous graphs. We have discrete graphs. Discrete graphs are just made of dots. Continuous graphs, those are the ones with lines and curves in them. So it would be perfectly okay, guys, to have, right, a graph that just has a collection of dots on it. That's okay. And we're actually going to see these in chapter 4. They're called scatter plots. Okay? Well, a certain kind of them. Not all of them are like that. Okay. Here we go. Make this a little bit bigger. Darlene, check it out. Each week, Darlene tracks the number of party hats her company has in stock. Okay? The table shows the weekly stock. Is this relationship a linear function? Use the graph to support your answer. Okay, so remember, figuring out if something's linear or non-linear from a table. All right, here we go. Are my weeks increasing at a constant rate? Yes, they're increasing at the rate of 1 for each little cell there. How about party hats? How are they increasing, or in this case, decreasing every week? So we go from 300 to 320. Sorry. We go from 300 to 250. Then we go from 250 to 200, 200 to 150, and so on and so on. So yes, I believe this number is going down by the same amount every time. That's 50. That means this is going to be constant. All right? So if we were going to graph this, guys, party hats here, weeks here. So at 0 weeks, I have 300 party hats. Bam. Right? After 1 week, I go down to 250. Okay? And then 200, and so on, and so on. Bam. How many weeks does it take until I'm out of party hats? That's right. If you said 6 weeks, you're good to go. All right? Is what I drew linear or non-linear, guys? Clearly, it's linear. Okay? And now we can hop into our last question. How can Darlene use the graph above to know when to order more party hats? Well, guys, our graph, sorry, it went away. I can bring it back. Remember, we started here at 300. We ended down here. All right, so there's what it looks like. So we just said at 6 weeks, she's already out of hats. So when should she order more? Probably sometime before she runs out of Hardy hats. Okay. So guys, there you go. That's what we got going on. So I know that was short and sweet. That was page 168, our key concepts. Now we're going to move on probably to our additional practice. All right, see you.